In this video, I'm going to talk about some safety analysis procedures. So, what basically safety is? Safety is it's just like the term that it says. Safety is basically we have a system, okay? We have a system, and in which we have uh, 2 to 3 subsystems, and we have in those subsystems we have 2 to 3 components. So we have to take each component and we have to consider its failure rate. Okay, we have to consider that how that component is going to fail and how it will behave when it has failed. So what we are doing here? We are going through the safety analysis. Okay, first the component being failed, the component being failed, before that time, at the point when it has failed, when it's going to fail, before that time we are doing the safety procedures. We are taking the possibilities that our component will fail and how it will going to behave when it has failed. So those are the safety procedures that we are taking. So for that, in safety analysis procedure, I have a tree for you just to define that what things comes in safety analysis procedures. What are different types of safety analysis procedures, and what are its scenarios, and how many scenarios it can be defined, and in how many procedures are to do the safety analysis procedures, how many more it can be subdivided. So let's have a look. We have two branches of safety analysis procedure. One is the inductive techniques and the other is the deductive techniques. Two techniques are present for safety analysis procedures. In the inductive technique, we have one the hardware failures and the one the procedural failures. What are the hardware failures? Hardware failures are the ones which are due to the circuit. We have a circuit. Suppose we have any circuit, a low pass filter or a high pass filter, anything like that, and in that circuit we have, in that subsystem, we have different components present. So that is the hardware of our, that circuit is the hardware of our system. So we are going to see the hardware failures, and for hardware failures we have quantitative analysis and semi-quantitative analysis. Hardware failures is further divided into two. In quantitative analysis we have RBD, reliability block diagram. I have bring this RBD. You know how to make the RBDs, and this for the series and parallel, and the further when we have different missions and different failure modes. So all these things, everything that comes in the RBD is in this quantitative analysis, and this quantitative analysis has brought out from this hardware failures. Okay, and the next is we have semi-quantitative analysis. In semi-quantitative analysis, what happens in this? We have two things present in this, two scenarios, two procedures are here. That is, one is the FMEA and the other is the FMECA. So what is FMEA? It's the failure modes and effect analysis. So what are the failure modes and the effect? What are their effect on our subsystem, on our system, or on our component? So those failure modes and their effect. So it's the complete analysis of failure modes and their effects. And the next is the FMECA. This is also basically the same thing. It's just when we have failure modes and effect and a critical analysis. So this one is the critical analysis. This one is a more critical one, and this one is the just effect analysis, and this is a critical one. So that's all for hardware failures. And what we have in the procedural failures? In procedural failures we have HFA, and HFA stands for human factor analysis. So this is the failures that are due to the human. Obviously when a human is doing something, is designing something, So there must be some human errors and human mistakes. There is a possibility of doing the mistakes of done by the human. So that is the human factor analysis, HFA, that comes in procedural failures. And now what is, we have the next one is the next safety analysis. First was the inductive technique and the next technique is deductive techniques. And what comes in deductive techniques, we have again the hardware failure, the procedural errors, and in hardware we have quantitative analysis and semi-quantitative analysis. So what comes in quantitative analysis, we have FTA, and in semi-quantitative analysis we have ETA. And what this FTA is, fault tree analysis, a complete method, a complete way of doing this, of defining this fault tree analysis has been done. It's done in the other videos, you can find from them, you can search it out from there. And for ETA we have event tree analysis. This is another thing, another complete method of doing the event tree analysis, of doing when we have semi-quantitative analysis and this all. So what we say now next, we have these both things are top-down techniques, and we are saying that these both are, they are bottom-up techniques. See, this is the bottom-up technique and this is the bottom-up technique. So what's these techniques are, this is the top-down technique and this is bottom-up technique. Okay, now in the next video I'm going to talk about, I'm going to describe in detail everything about this FMECA, this FTA and this ETA. So this was the part 1, and again then I describe what is top down technique and what is bottom up technique. So that's all for this video. If you want to know about these things also, you can visit the other videos, the next videos.